A chord rotates through a fixed point inside a circle. So, watch the midpoint as the chord moves through the fixed point P. It traces a perfect circle. But which circle? Let's find out. A line through P with coordinates 1, 2 cuts a circle x² plus y² equals 25. M is the midpoint of the chord. So, which of these 6 equations describes where M can be? For this circle, 0, 0 is the origin, the centre, with radius 5, and the point P is at place 1, 2 inside the circle. Any line through P will be a chord of the circle. M is the midpoint of that chord. So the question is, what is the equation, or more formally, the locus of points of M, as the line rotates around P? As the line rotates around P, M, the midpoint, moves. How can we determine which points lie on this circle? We can see it is a circle passing through both O and P. The midpoint of every chord through P lies on this circle. Now we need to prove it and find its equation. First, find the properties that determine this movement. We can see the radius of the larger circle passes through the midpoint of the chord and the centre. Hence, OM forms a right angle, i.e. is perpendicular with that chord. And this holds as we move the line for all chords. The angle OMP is always 90 degrees. And here's the geometry rule. If a point sees a fixed line segment at a right angle, it lies on a circle with that segment as its diameter. So M lies on a circle with OP as its diameter. This then allows us to work out its equation. Watch it happen. As the chord sweeps all the way around P, M traces out the complete circle with OP as the diameter. The centre is the midpoint of OP, that is a half and 1. The radius is half the length of OP. The centre is at half and 1. The radius is half the distance of OP. We can work out this distance using the distance formula, which turns out to be √5/2. Expanding the circle equation and simplifying, we find x² plus y² minus x minus 2y equals 0. That's the equation of the locus. Option D, x² plus y² minus 2xy equals 0. That's our answer. Options A and B, those are the large circle and a circle centered at P. So the answer is D. So the locus method, when a geometry constraint stays fixed at some values as something varies, that fixed constraint tells you the locus. Here, OM is always perpendicular to the chord. That right angle puts M on a circle with OP as a diameter. Find the fixed property, read off the locus. So a new TMUA question will be placed every day. So follow this channel and link and comment or share on a post and get 3 premium access to over 1,000 new TMUA style questions. All questions are made by me, Dr. Nicky Grant, with 3 Cambridge economics degrees and over 12 years experience lecturing at leading unis. I also have a good track record supporting Oxbridge applications for both TMUA and interviews.